Sorry, folks, for the behind-the-scenes stuff that's going on here. I'd like to welcome you to the Gateway to the Stars June 2020 program. My name is Don Ficken, and I'm with the St. Louis Astronomical Society. We've been partnering for a long time with the Gateway National Park. In non-COVID times, we actually do programs, live telescope viewing under the arch. And I'm also, by the way, president of the International Dark Sky chapter for the state of Mizar. And it's really great to have you. We've got a great program tonight. In fact, we would do this program each month through most of the year, and we have several good programs coming up, the Gateway to the Stars. On July 17th, we have Astronomy in the National Parks, which I think will be a terrific program. August 14th, another great program called Kids Explore Night. And then on September 18th, we'll have a program called Lights Out Apartment. So our program tonight will be broken into two parts. The first part, and I'm very excited, had a chance to talk a little bit with Joel Allen today. He's a local astronomer and a former Bryce Canyon, what's called a dark sky ranger, and I guess he can tell you what that means a little bit later. He's going to do a presentation first, and what we'll do at the end of the presentation is we'll have some live questions, and we are live streaming both on Zoom and also on Facebook. And so if you can be on Zoom, you can just put it into the Q&A area, and we'll pick those up at the end of his presentation, and we'll pass them along to Joel for him to answer. And then if you're on Facebook, just put them in the comments area, and we'll pick those up.
I didn't see your slide.
I'm sorry. Sorry about that, folks. We had a little trouble there. So that's okay. All right. And so after that, we'll have a second program. It'll be called Virtual Star Meeting, and what we'll be doing is taking a tour of the night sky with Stellarium, our park ranger, Rich Pepperman, who's been a long partner with us in terms of our Gateway to the Stars program. We'll do this really great job. He just does such a nice job of taking you through the night sky using it's a free program called Stellarium. And not only is Rich a park ranger, but he also happens to be a member of the St. Louis Astronomical Society. And after Rich does it's about a 20-minute program. We're going to go through some videos and images of night sky objects. Jeff Carpenter and Jim Small, both of the St. Louis Astronomical Society, will talk you through some of the really great objects you can see in the sky right now. Well, maybe not tonight, depends on how the actual weather is around here, but we'll go with that anyway. And we'll have live questions at the end of that. So what I'm going to do is I'm going to stop sharing screen, and I'm going to turn it over to Joel, and when he brings up his PowerPoint, I'll do a quick introduction of him and make sure he's got everything working, and we'll go from there. So just 1 second here. Okay, Joel, you'll pull up your PowerPoint, and I'll do a quick introduction for you.
Great.
Yeah, there you go.
There we go. How's that look?
That looks great. So we're excited to have Joel Allen to speak with us tonight. And Joel Allen fell in love with space in the meadow of an Ohio State park, looking through a small telescope at Saturn. He followed his love in college, where he studied volcanoes and planetary evolution. His joint love of geology and nature landed him a job at Bryce Canyon National Park. Wow, what fun that would have to be, where he showed visitors the rocks and biology by day and the stars by night. While he left that gig to teach his high school sciences 10 years ago, he's continued to set up his 5-foot tall telescope. Wow, 5-foot tall telescope, anti-jump for the public to share in the wonder of space. Currently, he and his wife are building a permaculture garden with many pocket jewel gardens. Their two cats are jealous they don't get to go outside, always to get to go outside. Joel teaches at the Principia School in Town and Country. With that, I'm going to turn it over to you, and I'm looking very much forward to hearing what you have to say, Joel. Thank you very much.
Well, thank you very much. It's an honor to be here. I love being contacted to do this because, especially during COVID times, I haven't been able to set up my telescope just out on the street and welcome people to peer through the same eyepiece. As Don was saying, I'm Dark Ranger Joel Allen. I currently teach at the Principia School, where I teach biology and field of natural history with one of my favorite colleagues. I'll be your guide tonight through the lives of stars. And what I just want you to take away with is, when you look up at the night sky and you see these stars, there's a lot going on, and there's so much wonder to be had. And hopefully that wonder just inspires you to start to think a little bit more about your attachment and a little bit more about your connection to space and just everything as a whole. And so to kind of get started in thinking about stars, they're kind of a lot like us. So all stars are born in the same way, just like we are all born in the same way. Stars have unique fingerprints, just like we do. And their different environments that they are born into give them different characteristics and different personalities, just like us, depending on where you're born and what characteristics you have innately. That will just kind of like weave into this mold to create you as a person. And stars have a lot of that going on as well. And so this kind of star psychology allows us to see the starry sky as a family quilt and to better see how they interact and how the universe has evolved with time. And I know that seems like a lot, but you know, as an 8-year-old, and I know the power of 8-year-olds, they can do a lot of thinking, a lot of deep thinking. And so they can make those connections possibly just as I did. And so as Don was saying, in rural Ohio, when I was young, about 8, my grandfather brought up from Evansville, Indiana, his little telescope, and he set it up in this meadow. And he asked me, what do you want to look at? So I pointed to a big bright light, and he's like, no, we're not going to look at that. Stars just look the same through a scope. Choose another one. So I did, and it was another big bright one. And he's just smiling. He said, no, let's look at this one. And so he had to lift me up, put me kind of on his hip, and let me peer through his telescope. And as he did, this is what I saw. Just nice and slow, I saw Saturn creeping across the night sky. I could see a few of its moons. I could see its rings. I could see the space between the rings and Saturn. And I was hooked. Just watching that, this usual ball of energy was just so still in his arms. And after it passed by, he set me back down and he said, now what do you want to look at again? And I was like, well, can I see that again? And so he held me up again after fixing the telescope and got me set to seeing Saturn again. And after that, I just started taking walks, started opening up star books, and I was just so curious about what was out there. My parents really started to encourage this interest, and they got a small telescope. And what I started to notice was that stars are a lot easier to look at than planets. And so although planets are beautiful, that when I did put my telescope on these stars, even though, yes, just like my granddad said, they look very much the same, I started to notice that some have gorgeous colors. Some, oh dear, it just died. Let's try that again. Sorry about that. Some of these animations, I guess, are pretty big. Great, here we are. So some have companions, so they're born as twins. Some have these really gorgeous colors as seen here in Vega, and all these stars are up in the sky tonight, even though we have clouds. And then some even can show their age just by their color. So you can be informed about what's the age of the star and how old is the universe, how old is that space. And what's also great is these elder stars have a lot to do with telling us about the distance in space, the distance across the universe. And so each individual star, even though it might look very similar through a telescope, what's significant is that they have an individual history and they can show us how they were born. Now, with humans, we all get this. A bunch of cells come together in mama's tummy, and then suddenly you have one handsome human, right? Well, if for stars, what about that? We get the human part, but for stars, it's a bunch of star stuff comes together in a comfy place, and a star is born. So it's kind of strange because, like, okay, with human birth, we get that human birth, okay. But what kids really need to be asking is, what is the star stuff? And what's the event that brings it all together? So in the universe, it's mostly made of hydrogen. That's what you see here. It's just hydrogen. And 3% of it is about helium. But for everything else, like the carbon and the oxygen that makes life, the silica in my glasses or in concrete, to make everything that's not hydrogen and helium, you need to go to a 1,000%, so very, very small amount. And so it's all mostly just hydrogen kicking around in space. And in this hydrogen has a thing called spin. Spin is energy. And so gravity can't pull in the hyperactive, these very fast moving ones. It's only the calm star stuff that comes together under gravity. And as they get close, the gravity intensifies, there's friction, there's light, and it's like the stellar dance party where you just have all of this light flashing and going around these beautiful things. And that's how babies are made, star babies. That's how star babies are made, with the friction and the stuff coming together. And so they get this light, these stellar nurseries, these places where stars are born, from all of this hydrogen coming together and creating this pink light. This pink light isn't made from stars, it's made from this material coming together and having this friction to essentially make protostars. And each one of these stellar nurseries can make thousands or tens of thousands of stars. So don't think that this one nebula is going to make one star. Indeed, you can see in this image, it's already made hundreds. And so this star stuff is all around, and the chill stuff gathers together under gravity, which makes this pinkish. Okay, but what happens then? Well, in that star stuff, we've got to bring it together. For a star to be made, we need this thing called fusion, where the bonding of all of this stuff coming together creates this light, pushes out with this big force, and we call this fusion. Now, when I was learning about astronomy, I would learn the bread analogy, where fusion is like if you take a loaf of bread and you sit on it. And that made no sense to me. With the sitting on a loaf of bread, you still have a loaf of bread that's just now squished, and nobody wants to eat that. It's still bread. And with fusion, it's different. You're starting with hydrogen, the stuff that's out there in the universe, and you're bonding this together through a series of reactions, letting off this stuff. And then you end up with helium, protons, and stuff. And so it's not like bread. You're making something different than bread. And so in this fusion analogy, it's a whole lot better if we think of cheese puffs. Now, think for a second, how many cheese puffs can you fit in your mouth? For me, it's about 9. And you see, I can get like a few over here in this cheek and a few over here before I start laughing. And when I laugh, like my jaw's going to start to condense, and I'm trying to go for like number 10. And that's immediately when I start to feel a cheese puff just kind of go, and suddenly I've changed the cheese puff. It's no longer a cheese puff. I've got something totally different. I've got a Cheeto. This is fusion. It's not like bread. It's with cheese puffs and Cheetos. And I'll keep jamming in cheese puffs. It's always cheese puffs, always hydrogen, into my mouth. And eventually those Cheetos are going to smush into a Cheez-It. That's fusion. It's not squishing bread. It's changing always cheese puffs into Cheetos and then into Cheez-Its. And so with this, as you're shoving these things in, of course, it's going to be kind of weird and you're going to laugh. And so crumbs and stuff are going to come flying out of your face. I know that sounds a little gross, but that is actually really important. It's really essential to the whole star birth process. You see it the whole time, all of those cheese puffs are collapsing in, trying to get close to that mouth, to that central point, to where the sun is starting. And as it does so, and the fusion kicks on, all of that stuff, those crumbs and that stuff exiting your face is going to push away all those cheese puffs. It's going to push away the gas. And this is what happens when a star is born. As soon as fusion starts, fusion kicks in, and you're making Cheetos or Cheez-Its, you're going to push away that gas. Now, these are just illustrations. What does it really look like? Well, in about 2001, we were able to find an image, an actual image in the Orion Nebula of a star turning on, of a star being birthed. So this is a star being born right here. And as you can see, that little darker ring around that star is all of the gas and dust being cleared out. It's by the crumbs and the stuff coming out, that ejecta of cheese puffs that is pushing out that cloud. And it's those crumbs that are essential for planets. So as soon as that stuff goes out, it's acting as like a giant blast of solar wind, a giant solar sneeze, just a really big shoo. And as it blows out, the heavy elements and rocks are going to remain close to the sun. And the gas and the light dust is going to go way, way, way far out. It's no happenstance that close to our sun, we have the rocky planets of Mercury, Venus, Earth, Mars. And then much, much, much farther out, we have, like what we can see in this image, a big gas giant. And then even beyond the planets, the wind keeps going. The gas keeps going. As the gas keeps going, it interacts with the nebulous space around there. So the nebula, the same nebula from which was born, it starts to interact with its solar wind and pushing it out, as we see here in the bubble nebula. It pushes out even more, forcing the fusion and birth of other stars, as seen here in the Heart Nebula. And then even here in the pillars of creation. Now, some of you know also these are the pillars of creation. And you know these from a famous National Geographic image, but in the pink here, we have the mountains of creation, so much larger. And the way that these mountains and pillars are being formed is from giant stars, off image, off screen, that are pushing with their stellar wind, almost like wind against pollen or snow on a car. And so as soon as you start to drive and that wind blows on that snow will pile up and build in some places and be brushed off in other places. And at the tips of these cones, we end up having whole groups of stars being born. And as you can see, these nebulas aren't well mixed. They aren't homogeneous. There are some areas where the molecules and the gas and dust are dense, some places where they're pink, where they're white, where they're dull. And all of these differences are representations of the amounts of iron or calcium, uranium, and even organic molecules, things from when past planets that had life on it had been singed and their molecules had been floating around out in space, now finally coming together to make new stars and new planets. And so when a star is formed, each is going to be unique. Now, when you look at stars through a telescope, the colors and brightnesses can tell you a few of these things. They can tell you the temperature. They can give you an idea of like how bright they are, maybe how massive they are. But if you really want to know the individual of this star and where it is in its life, you have to look at the whole spectrum of their character. You have to look at it in a different way. This scientist is looking at stars. This is the famous astronomer, Annie Jump Cannon, for whom I named my telescope after. She worked at Harvard for over 40 years, cataloging and classifying stars. And in a time when most women were expected to get married and clean houses, Annie Jump Cannon demonstrated that women could best any man in organizing and interpreting this data. She cataloged around 350,000 stars, was the first woman president of the Astronomical Society, and developed the classification system for stars that we still use today. The expectations and barriers were astronomically high for her. And so just for thinking about this in a moment, think about how many more people like Cannon could brighten our societies with their shine, with just a little bit more of a just playing field. It took a very special someone to decode what she is seeing on this plate, where she's got one eye closed. Do those really look at all like stars on that plate, that image she's looking at? I mean, do you see how they look smudged or streaked? That's because what they did was they did something weird. Before they took a photo of the stars, they put a prism in between the light from the stars and their camera. And this spread out the light of the stars like a rainbow, okay? And so each rainbow is each a different star. And when we look at these different rainbows, we're looking at the different elements that each star is made of. We're able to see how truly bright it is, how massive it is. We're able to see even a little bit of it, where it was born, because each of these dark bands represents an element that star has. And if a star has that element, that gives you an idea of where it was born. Because just as we were looking at the mountains of creation, and it wasn't all homogeneous, wasn't all well mixed, if a star has certain elements, that isolates and identifies a few locations where it could have come from. While Annie Jump didn't invent this method, she certainly was the absolute best at identifying these stars and identifying the personalities of stars in general. This is a really famous image that you'll find in astronomy. And before you get very confused, because there's a lot going on, no, this is not a game of marbles. You don't like start at the top and like roll your marble down into the red. There's no secret necessarily trap door to suddenly appear in different places. Okay, this is in some ways a personality chart of stars. Using Annie's catalog, astronomers identified that the color that we have is based on temperature. So very blue means very hot, white is kind of mid-range, and red is very cool. Okay, and then the brightness, the luminosity, it has everything to do with helping to identify the star's mass and its size, which are two different things. The size determines how the star will live. Either the star is going to live very fast and brilliant, like the stars up at the top, or it is going to be very slow and Zen-like and last for trillions of years, like the stars down at the bottom above M. And so when we look at this, it's truly something more of a personality chart. Now, when a star forms, its mass is set and it determines the size and how fast fusion burns. So from a nebula, it'll get a certain amount of mass and then land somewhere on this chart. And then it's not going to change all that much. Its mass is set and it'll change a little bit in its temperature as it cools and expands with time. And so out of this, what we can do is we can look at this as a personality, where your supergiants don't last very long. They're around maybe about 1 million years or a couple million years. These are our Lindsay Lohans, James Deans, like suddenly one day in just a really tight white shirt, take a motorcycle, drive off a cliff, or shave your head. Just something really extreme. They aren't around for very long. The main sequence, this is most of us. Most of us fall along here. We're going about our lives. We're not causing too much of a stir. Everything is going to be fine. We're going to last a while. But on this main sequence, there are some ringers. Like, say, for instance, Mick Jagger, there are a lot of people who are like, that guy's not going to be with us very long. And then suddenly you're like, wow, you're like 86. That's amazing. 76. Yeah. Wow. Good on you. Okay. And so just by the color isn't enough to just tell you what's happening about the star. You need a little bit more about the mass, the actual size and the influence of the star. The giants, whether it's a super giant that's red or just a giant star, these are our elder stars. These are the stars that have lived most of their life. They're maybe about, anywhere from about 1 trillion or 10 billion years old, depending on how massive they are, because it's very small means Zen-like, so they're going to last a long time, like my grandparents. And then the brown dwarfs, these are your Zen masters. They're going to be around for a long, long time. And we look at their mass, and we calculate how fast they fuse the hydrogen in there. We come up with answers like 1 trillion years, which is totally different than our Lindsay Lohans, which only last about 1 million years. It's a very different number. And then lastly, the white dwarfs, those are our skeleton stars. You get to be a white dwarf when you're just the core and you've lost the entire plasma cover that wraps up most stars. See, all these other stars have this big gas plasma cloud around them where this gas is clamoring to become part of that core. And the white dwarfs have just puffed that off. And so all you're left with is the core. And so like us, the places where we are born and what we are born with kind of matter. The personalities of these stars are determined based on where these stars grow up and what they started with. Where the analogy really falls apart is, however, we as humans are offered the opportunity and the choice to continually change our character. Stars cannot. Stars are locked in, often even with other stars. A lot of stars are often born as twins. Our star is not. Our star is singular, and it's not a rarity, but it's not necessarily like the most common thing. For instance, stars will even be born as triplets, or here in the case of the Gemini twins, we can find Castor Castor is a sextuplet star. It's got 6 different stars to it. If we just take a look at it with a basic telescope, you might see 1, maybe you can see that there are 2 down here at the very bottom. And so you might think there are 3, but hold on. When we really zoom into these, we find that each one of those 3 is more stars. For instance, this one that's way far out is actually 2 stars. These 2 that are down in the bottom corner, each of those is 2 stars. These are all stars that were born very close together at the same time from the same nebula. And because of that, they all orbit each other. They're all in this balance and in this dance. Now, yeah, they're about 2 light years apart. If you take a look at, Castor C and Castor A and B, and you might think, wow, that's really, really far. But it's important not to see stars as isolated individuals. And it's important not to think of light years as truly vast when you're understanding the universe. It's important to see with the vastness of space and time and see these great distances as more close proximities. For instance, if we take a look at these groupings, imagine that Castor A and B, these whitish blue ones, are just in a kitchen, whereas Castor C, the 2 red ones, they're out in the dining room setting the table. They're very, very close. I mean, even 4 to 10 light years, that's like being in the next house, just right next door. It's all very, very close because stars take up a very, very big space, and they'll even move with time. So here's a very familiar constellation, the Big Dipper. Most of these stars in the Big Dipper were born of the same stellar nursery, so from the same nebula. And I'm interested to see if you can guess which ones. Start with looking at the color. Look at the color of those stars and see if you find any similarities. And just make a guess, make a choice. Now I'm going to give you the light year difference. Which stars do you think were born of the same stellar nursery and are kind of companions? Okay. If we again notice the color, and I put the 2 together and really help you with that color, you can start to see that it's these stars here in the center. I turn on my laser pointer, it'll be a little bit more easier to see. These stars right here. It's those stars right there that are all companions. They were born in the same stellar nursery together. While they are not necessarily orbiting each other, they're all traveling together. We're very fortunate to have the Big Dipper as a constellation. The Big Dipper has not existed for very long, and it is going to change over time. So tonight, we might see the Big Dipper as this. Over the next 75,000 years, it'll be this. And then in about 100,000 years, it'll no longer be the Big Dipper. It'll be something more like the Big Spatula. And so the rate at which stars are moving about our universe is helpful to us so that we understand that stars aren't necessarily set in stone. They aren't set in one exact place. And the night sky that we have is a unique treasure. It's something that should be cherished as something that's unique and impermanent. And what's also interesting to think about is to think about it in the reverse. If the people before us, especially our ancestors who were walking across Africa 2.5 million years ago, if they didn't have this, what stars did they have? What were their unique constellations? What were their unique wanderings that they had with an entirely different night sky? Like all stars eventually, though, these 6 here will explode and will not be around for all eternity. As they get old, they're first going to go through a few phase changes. Now, all stars go through this giant phase. And what's happening is the star is going to collapse. And the way that it starts to collapse is with the core. The core is going to start to do higher orders of fusion. So going from like the Cheeto phase to the Cheez-It, or the Cheez-It phase to an entire cheese ball. And as it begins this higher order fusion, the core collapses. As it does, the gravity, the location of the gravity of the core stays the same, but the core gets further away from the edge of that star, And it also increases in solar wind, which pushes out this gaseous plasma ball surrounding, being held in by the gravity of the core. And it's going to do it even again. So the core is going to collapse as it maybe starts to make iron at the core. And as it does this, it's going to have such a massive stellar wind that it's going to be able to even push through and get out of that plasma membrane. We call these stellar outbursts, light echoes, because what's happening is this energy is pushing out and it's echoing and just exciting all of the gas and the dust of interstellar space. All stars go through this variability, this period in time where there is an imbalance between the gravity of the core holding in and the pressure of fusion pushing out. And the moment that there is no longer this balance between gravity and pressure is when the star dies. This is going to happen in one of two ways, what it looks like. If you're a star like ours, at the end of life, you return to gas and dust. You have a big last pulse of solar wind that pushes out the gas and dust. We call these planetary nebula because back in the day, they were looking at these and they thought this is where planets formed and what it looked like where planets formed. You know different now, thinking all the way back to that tiny little star surrounded by that blue dust and with that little bit of gap in the middle, right outside the star. These are stellar deaths. In the center of each, you have a core, the core of the star that had collapsed so much, created a massive stellar wind, and blew the rest of the plasma away. Based on how the star is rotating and its orientation to us, we'll see something different. For instance, here's the Ring Nebula. In the middle there is the core of that star. And what we are doing is pretty much looking straight down the North Pole. If you think of a star as kind of like our planet, North Pole and the South Pole, you're looking straight down the barrel of it such that when the star exploded, it exploded like a ring. This star down here, the Spirograph Nebula, is pretty cool. The interesting pattern of arcs shows us that this star had companions, at least one, maybe several companion stars, such that as it started to explode and erupt and lost its gas, it let go of its companions in its death. But as its companion stars drifted away in an arc away from that star, they left these gravitational waves kind of trapped or echoed within this nebula. Here we have the Eskimo Nebula, and here we have the Eye Nebula. Each of these is made of different elements. For instance, in here is, I recall, the oxygen is about this pink inner portion. The hydrogen and some of the carbon is red. And so by understanding that these different colors tell us the elements of these stars, even in their death, we can start to harken back to understand what was the life of this star? How big was it? How bright was it? How long ago did it was born? We can look at those things, looking back at just this evidence. These planetary nebula only last for about 30,000 years. And so hopefully you get a chance to see them while you can. The other way a star will die is in a complete opposite. Instead of solar wind winning and pushing out the plasma, instead gravity wins and pulls in the entire star plasma, and it echoes right off of the core, shredding it to bits, shredding it to pieces. And this is what you know as a supernova. They are so bright that you would be able to see them even in the day. They would just hang out in the sky for maybe a couple of weeks. And if it got dark and you could put a telescope on them, you would notice that there is no core star, that the star had pretty much been shredded into oblivion. But still, like the other stars, even though we're only left with ribbons, we can look at the elements and understand the life of these stars, the life that they had. What's phenomenal about these stars, and the ones that shred themselves to bits, is that they are recognized as something important and significant not just by us, not just by astronomers, not just by the public fascinated with something new happening, but they are so intriguing that even people before us have recorded them. Here in Chaco Canyon, there is this pictograph, this painting on stone of a moon, this spirally bright thing, and then a handprint. And when we date this, when this is dated, it's dated pretty much to the time that this supernova would have exploded back in about, I think it was like 10,000 AD. And we have this right here, and we believe that, and the moon would have been in this phase when that supernova exploded. And this handprint, we believe, is the artist's signature. And so for in this, what we can definitely tell is that you and I are not the first to be, and nor is Annie Jump, and nor is Galileo, the very first people to be truly interested and intrigued and full of wonder by the night sky. And I don't think that will ever stop. And so when we have this curiosity and this love for the night sky, one of the things we definitely have to do is start to think about it, protecting it, so that we and those who come after us and the loved ones that we have, so that we can share this amazing thing with them and help them start to see these individual pinpricks in this bluish black sky as something wondrous that's happening, and something that's wondrous and changing before our eyes. And one of the biggest issues that we have right now is light pollution. And now, while I could give you the whole talk about light pollution, and you might be like, well, I need my lights so for safety and things. Yeah, I'm right there with you. So do I. But what's interesting about this is that oftentimes those creating the most light pollution don't know what you and I know. So I'm not going to give you the light pollution talk of saying, you know, buy blinds so you can shutter and stop the light from going outside in the middle of the night. Instead, what I'm going to ask you to do is just share your love of the night sky with others. Because I've just gotten so many friends into astronomy just by suggesting a road. Like, hey, have you ever been out on like 166 in like the middle of the night? Like, no, seriously, like go out 10 miles. And then like maybe a month will pass and they'll come back and be like, oh my gosh, I thought you needed a telescope to see something like that. And I'll be like, no, it's just there. Just a quick drive out into the country and you're there. Even for us here in Missouri, we've got some really dark night skies just to the west and the south. Even just down in Eminence, Missouri, you can find some amazing, amazing starry skies. And there's so many who don't know that it's there as a resource and are missing that wonder and that appreciation and that inspiration that you and I already have a connection to. And so to help us protect the night sky, I just hope that you share your love and your interest with the night sky with others. With that, enjoy your night skies. Thank you.
Well, thank you, Joel. That was awesome. I apologize for some of you that was watching on Facebook. We had a little delay of starting the presentation. We will be posting the full presentation back on the Facebook page. But it was really a great presentation. I can tell that you've got passion both for astronomy as well as the night sky itself, and it really comes through. And I'd love to hear sometime of your stories about Bryce Canyon. I bet that was a lot of fun by itself, right?
Most definitely.
Yeah. So we had one of the folks that was asking about what part of the sky was featured on your title slide. This is coming from Zoom, and I believe that was Saturn. Is that right? I was trying to remember what you had back in your first object that came across the screen. That I think it was Saturn. It was one of the people's favorite, right? When you were first.
Saturn was was not on the title slide, but it was the first planet that went across. On the title slide was it's where it said the lives of stars, was the Saturn deep field. So there's this glorious field of Sagittarius. There's this fantastic location near Sagittarius, the constellation, that just has all of these beautiful gem-like stars. It's hard to see even with my 12-inch telescope, a really large aperture telescope that I have, but it's really nice if you can set up a camera that can be steady on it, and also just take a look on the Hubble website.
Wow, that's great. Okay, let's see here. What else do we have? Jim, if you're on there too, if you're an educator, why don't you ask some questions? I'm trying to check the different questions here to see what's out there. So if you've got some questions.
Well, I was going to point out one thing, and that's if you look at the background behind me, that's a thunderstorm. Let me get out of the way so you can see the lightning. But that was taken while I was at Rainbow Point in Bryce Canyon.
That's a beautiful
Which is
location.
a fantastic place to view the skies. So if you're traveling out west, definitely stop by there if you get a chance.
Looks like we had somebody that had a Meade ETX 125 that when I was much older than 8, when you saw it, I guess that they were captivated, I guess, by Saturn as well. I would say that most people, when they see Saturn or anything like that, even naked eye, or maybe particularly through a telescope, it's quite amazing really to look at it, right?
I'm sorry. I was reading a question from the Q&A. Was that a question to me?
Yeah, that was basically.
Sorry.
Yeah, so basically they looked at, I guess it was Saturn through an ETX 125, and they were that was their first light, I guess, of that particular telescope. So it's got to be exciting, right?
Beautiful. Yeah. For something like Saturn, to give a telescope first light, which is like when we're finally looking through a telescope for the first time right out of the box, to see Saturn and just be smacked with that of what possibilities you have with the telescope. To see the rest of the night sky is it's just one of those things where you just will put it back on Saturn again and again, just completely in disbelief. My favorite reaction from people when they see Saturn is immediately when they turn to look down the telescope, wondering if I'm projecting an image of Saturn, or I've got it glued onto some sort of image or the ocular, because it's in just such stark detail.
Yeah, it looks just like the picture.
It does. It does. So I saw a question from the Q&A, and someone was asking if that's a Tyler Nordgren event on the wall, and it totally is. That's back from when in 2012 when we had the annular solar eclipse in Bryce, and Tyler made this gorgeous print of the sun slowly sinking into the sky right where it hit annularity, and that was an amazing experience. I got to be a ranger there, and I was in charge of one of the outposts where we had a bunch of telescopes. And during annularity, if you turn around and you put your back to the sun, you'll actually see that you have multiple shadows because light is coming from opposite ends of the sun. And for those of you who are like, why in the world are they talking about Tyler Nordgren? Tyler will be here giving a talk on July 17th, I think it is, isn't it?
That's right. Astronomy in the National Parks. We get the next Gateway to the Stars.
Yeah.
That's cool.
Yeah, and talk about enthusiasm. Tyler's got it.
Yeah, it really is. And it's been really fantastic having someone of his caliber in astronomy start to really push the boundaries as to what can be interpreted. Because for so many of us, as when we start off as amateur astronomers, we're thinking oh my gosh, don't show me the data. I'm not too sure I can handle it. Or what in the world is that graphic? And Tyler's just been doing a great job, just like Neil deGrasse Tyson, of being no. Everybody's smart. Everybody can handle this information. It's about how it's presented and with what purpose.
Yeah, that's one of the things that we talk about sometimes. We sometimes think so much about the visual side of things, but at the end of the day, there's also artistic ways to express yourself, right? There's
totally
mathematics that's involved in this, and so there's many ways to connect with it. So if anything else you want to add about your presentation? It was very, very good. I know that you said you had some longer versions of it, and I almost would have liked to heard it actually, because I was trying to work a couple of things in the back here, trying to get some things to work, but I'm saying I really got to pay attention to what he's talking about, right? So
yeah, well, it was So when I would give it at Bryce, oftentimes it was given starting anywhere from about 8 to 9. And at Bryce, it's so on the far edge of the time zone that you'll end up with people coming out after like a 30-minute presentation, and it's still so bright. And so it got to the point where they were like, no, make a presentation that's like 58 minutes long. And, because it's like, otherwise they're going to come out and it's going to still be so bright and we're going to have nothing to see them, and then they're going to go home.
Yeah.
And so I would add in to the presentation a number of possible things that they would see. And so stars that they could see, whether those are things sort of like companion stars like Albireo, or constellations that they could look for, and how they could find other objects in those constellations, whether those were galaxies or other star clusters. I would talk about sunspots and how stars in their plasma, as the plasma rotates, it rotates at different speeds at different locations, and how that warps the magnetic field. And I would use the analogy as like, those are like temper tantrums. And so every once in a while, or like midlife crises, where every once in a while, it's like we go through some sort of sea change. Well, so do stars. And stars have these times where they just end up ripping themselves to pieces. And when you look at sunspots, that's what you're looking at. You might not be able to see the magnetic field, but that right there is an expression of how the magnetism, or the pluses and minuses, the charges on the surface, are just ripping itself to pieces. And it's pretty awesome to think about this thing that you can't see just being expressed as this little tiny dot, and exercising that wonder to think about like the torrent that's actually happening on a magnetic sense.
Yeah. It's always amazing to me when I look at the stars, and they all look like they're exactly the same distance. They're just on a board up there, and they're all little dots. But the distances that you're pointing out, the significant distances, and sometimes the brighter ones are not necessarily they fool you in terms of how far away they are, because they're so big, and that's really quite amazing.
Yeah.
It shows the vastness of everything, right?
Yeah. And one of the pieces that I ended up cutting, I had a few things about how Henrietta Swan Leavitt, who is a contemporary and actually in the same lab group as Annie Jump Cannon, how she used variable stars, so elder stars that are pulsing with their brightness. She used those stars to start to identify that there are different galaxies. Because before that period, if you'll recall, everybody thought that there was only one galaxy in the entire universe. And Henrietta is like looking at these photographic plates, finding these other variable stars, investigating them, figuring out how far away they have to be. And as soon as she's coming up with these numbers, thankfully, the few people, and they had to be men at the time, totally believed her and got other astronomers to listen to her and to take a look at the data. And then they were like, oh my gosh, what a phenomenal discovery. Thank you. Because it just blew the doors open as to the vastness, as you say, of space.
Yeah. This has really been awesome, Joel. This is really great. And we are going to post the entire program after we get done tonight to the St. Louis Astronomical page. I just notified that that's the place that they want us to put it. So you'll be able to watch everything in its entirety. And if you're like me, you'll probably watch it 2 or 3 times, Joel, so I can take all my good notes from what you were talking about. That's really good. I love some of the charts. Of course, I've seen some of those before, but you're putting it together, and you should do such a great job of putting some enthusiasm behind it, which makes it so much more attractive at the end of the day, right? So,
well, thank you.
Well, that's great. All right, so what we're going to do.
Tim has a question or an idea.
Sorry, yes.
I was going to make one more comment. Another Bryce Canyon photograph behind me, and just in case you can't think, you can't do this kind of work. That's just a 30-second exposure with a regular DSLR on 50mm lens. So you can get some phenomenal views and take images like this just with a regular camera and a tripod. And you can either set it on 10-second delay so you don't vibrate, but again, it's another view from the fantastic skies at Bryce Canyon.
All right, great. Well, thank you, Joel. And so what we're going to do now is we're going to move on to the second part of our program. And you're welcome to hang around, Joel. We've got
thank you.
A great Stellarium, if I can figure out how to operate this thing here. So it seems like we've had a couple of technical challenges tonight. So just give me a moment here as I get this queued up, and I'll be right back. What I'm going to do is I'm going to queue up a pre-recorded video on a Stellarium tour of the night sky. It's really done nicely. So hang on just 1 minute.
So Jim, what other places do you like to go to?
One of my favorites is Arches National Park, but I've never done much astronomy work down there.
Mhm.
Around here, we go to some of the local dark sites. Those are nice to get out to as soon as I can. But yeah, I like everything out west.
Yeah, out west is a pretty special place, especially with how warm and dry it is. Makes for really great seeing, really great observation.
All right, guys, I'm going to play this video. Tell me for sure that it's actually giving some sound and all that good stuff, if you could.
Featured at Gateway Arch National Park.
Getting that okay?
Yep.
All right, thank you. So this is a pre-recorded video here of a Stellarium tour of the night sky by our good friend Rich Pfefferman. He's a park ranger and also a member of the St. Louis Astronomical Society. Hang around, this is a good one. I enjoy the way he does his work here.
For the next 20 minutes or so, I will be taking you on a tour of some of the things that you can find in the night sky in June. Most of the things I'll be describing can be found with your unaided eye, even if you have a lot of city lights. If you can find a spot that's a little darker and has an open view, or if you can bring binoculars along, that can help. This tour uses the Stellarium planetarium program, which gives a pretty realistic version of the night sky and also allows me to demonstrate the motions of the sky. So now we're going to switch over to Stellarium. And here we go. You know, it's often good in stargazing to start in the western sky and finish in the east. This is because as the Earth rotates, the stars and planets in the west will get lower and lower and set first, while those in the east will rise higher and get easier to see. Go out about 30 to 45 minutes after sunset, or around 9 o'clock in St. Louis this month, and you should have no problem in finding the planet Venus as the bright star-like object low in the west-northwest sky. Hey, wait a minute. Where is it? There's a tree in the way. This tree. That reminds us that you need to find a spot with an open view to the west-northwest horizon to spot Venus. You can get there on foot or hop in your car, but all I have to do is to click a button to get rid of that tree, just like this. There you go. Although Venus will still be easy to spot if you have that open view, it's going to remain pretty low in the twilight sky for the rest of the summer, dimmed quite a bit by the sun's glare. The best part of Venus's evening show this year will be this fall and early winter. As the Earth rotates, it will get darker out and more stars will become visible. We'll show that now. Move ahead in time just a little bit. There we go. This is about 40 minutes later, and by this time Venus is setting, but the sky is darker. Early in June, you can still get a last glimpse of the Gateway Arch's counterpart in the sky, the Arch of Spring. The centerpieces of the Arch of Spring are the Gemini twins, Pollux and Castor, side by side in the western sky. If you have an open view to the horizon, the south leg of the Arch of Spring is formed by the star Procyon, and the north leg by Menkainen and Capella. You do have a pretty good arch there, I would say. Remember to find that open view and look early in the evening and early in the month. As you can see in this image, the celestial arch has an intruder this June, the planet Mars. Mars is on the far side of the Sun now and shines only about a 40th as bright as it did when it was nearby last fall, but you can still spot its reddish-orange color if you look closely. As the Moon revolves around the Earth, we could watch it emerge into the evening sky and pass first Venus on the 11th and Mars on the 13th. The Moon will be coming into view. Yes, here's the 11th. I'm going to enlarge the view a little bit so we can see the Moon a little bit better. Here we go. So the Moon on the 11th, just to the lower right of Venus, very low in the sky. And then on the 13th, it's going to be pretty close to Mars. This thin crescent will be very pretty, and if it's a good clear night, you can notice the outline of the unlit part of the Moon, faintly illuminated by sunlight reflecting off the Earth onto the Moon and then back again. This is called Earthshine. Here is a picture I took of the Earth-lit Moon last month when it was passing the planet Mercury. So we've already seen how Earth's turning and the Moon's revolution around the Earth affect the sky. There is also the motion of the planets around the Sun, which cause them to shift their position relative to the background stars, which are thousands of times farther away. Venus and Mars are having a race this June and July in the western sky. Which one wins? Well, let's see. Let's go back to where we originally started at the first of the month. Go backwards. Here we are back to June 1st. We can see that Mars starts out June well ahead of Venus. Chugging along in its orbit, Mars appears in line with the Gemini twins around the 8th, right about there, and then continues on. Since Venus is closer to the Sun than the Earth is, it takes 224 days, or about 7.5 months, to go around once. Since Mars is farther from the Sun than the Earth is, it takes almost 2 years, or 687 days, to do the same. So by June 25th, as we continue on, we can see that Venus is now the one that's even with the Gemini twins, and it's steadily closing in on Mars. We will witness the exciting conclusion of this race next month around July 11th. I won't give away whether Mars or Venus wins, but if I were you, I would bet on the one whose name starts with V. If you think about all this, it's pretty cool. All of these things, Earth's turning each day, the Moon revolving around the Earth, and Venus, Mars, and the Earth revolving around the Sun, we can see them with this simple Stellarium computer program, or even better, in the real sky. And you don't even need any special equipment. That's one of the great things about stargazing. Now, the next bright star to the upper left of Mars and the Gemini twins is the heart of Leo the Lion, the star Regulus. Let's go back into position here and get our landscape back so it's more like what you'd see in the real sky. Now, Leo is one of the constellations that looks a little bit like the thing that it's named for, if you have a dark enough sky or use binoculars to fill in the blanks caused by the city lights being too bright to see some of the stars. You can imagine this backwards question mark of stars forming the lion's head and front part, and then the triangle here making up the hind part and the tail. Do you have trouble seeing a lion there? How about this? I'll draw in the constellation lines like this. There you go, that's Leo the lion. Or we can imagine how the ancients saw it, having the time to create their stories and legends about the sky. To the ancient Greeks, the constellation Leo represents the Nemean lion that terrorized the countryside. The god sent Heracles, known to the Romans as Hercules, to slay the lion. The mighty hero tried to shoot the lion full of arrows, only to find that they all bounced off. Finally, Heracles had to strangle the lion with his bare hands. After that, Heracles wore the lion's skin as his cloak, and both were placed into the sky to recall the event. We've covered all the action in the western part of the sky, so now we're going to shift our attention to the north. High in the sky are the stars of the Big Dipper, a plow to the British. 3 stars form the handle, and 4 form the bowl. All but 1 are pretty bright, what we call second magnitude, but the star that joins the bowl and the handle is dimmer at third magnitude, and it can be hard to see if you have too many city lights. Take a close look at Mizar, the star at the bend in the handle. Can you spot a tiny star named Alcor right next to it? I'll scroll in. There you go, you're starting to see it there right now. And there's a little tiny satellite going on the computer program. Again, if you have a good enough sky, you may be able to spot Alcor with your unaided eye. Otherwise, you'll want to break out the binoculars. A telescope will reveal that Mizar is itself a much closer binary star. As many people know, the stars in the Big Dipper's bowl, the 2 stars farthest from the handle, always point to the North Star, Polaris. If you imagine a line from the center of the Earth through the North Pole and then out into space, it goes almost exactly to Polaris. Many people think that Polaris is the brightest star in the sky, but as you can see here, it isn't. It still is pretty bright at second magnitude, though, enough to serve as a great landmark. The stars of the Little Dipper curve upward from Polaris and are mostly hard to see from near to the city, but these 2 make up the guardians of the pole, and they're fairly bright. The Big and Little Dippers are not actually constellations themselves, but they're part of a larger pattern, the Greater and Lesser Bears. These patterns are very hard to see, but I'll bring up the animation again to show you the pictures that the ancients drew. You can see that the Little Dipper there, Ursa Minor, has a very long tail. Now, as I talked about last month, you could use the Big Dipper to help locate several more bright stars in the sky. If you draw a line not through the pointers, but through the other 2 stars in the bowl and go the other direction, we can confirm our identification of Regulus and Leo the lion, which I talked about a couple of minutes ago. just like that. If you follow the arc of the Big Dipper's handle, you can also spot the very bright star Arcturus. We'll come around to see that. Get a little bit larger scale. The Big Dipper's handle, follow the arc to Arcturus, and then speed on, or some say spike, to Spica, two bright stars. Now Arcturus is a giant star, pretty nearby as stars go, at 37 light years away. Spica is dimmer but still bright, and it's 250 light years away. So the light from Spica left at around the time of the American Revolution, and it's taken that long to get to your eyes. So this is a case where appearances are deceiving. Although Arcturus looks about twice as bright as Spica, Spica would be about 20 times brighter if they were both at the same distance from us. You might also notice that Arcturus shines with a noticeably yellowish-orange tint, while Spica is white, maybe even tinged a little bit with blue due to their differing temperatures. Now there's another orange-colored bright star that you could find at this time of year low in the southeastern sky, and that is Antares at the center of the constellation Scorpius. The Scorpion is one of the most distinctive constellations in the sky, and I plan to talk more about it next month. My last stop in the sky tour is the east. Three bright stars in the east form the huge summer triangle, which I'll be talking about for the next few months. Vega is the closest to the Earth of the three, just 25 light years away. It's also the highest in the sky. Altair, lowest, 16 light years away, so quite close. And then Deneb is fantastically far away, about 1,500 light years away. And these three make up the summer triangle. They're still fairly low in the sky in the early evening in June, but they'll get higher as the night goes on. Before I go, I want to mention our next two Gateway to the Stars programs. On June 19th at 8 p.m., Mr. Joel Allen is going to be our guest speaker. He's going to talk about the lives of stars. He's a local astronomer and is a former park ranger at Bryce Canyon National Park, which offers some of the darkest skies in the United States, if not the world. I've sort of picked up the nickname myself of being the Sky Ranger. Well, those similar to me at Bryce Canyon are known as Dark Rangers. So this program should be a lot of fun, and it'll be followed by this video tour and then live or recorded images of sky objects submitted by members of the St. Louis Astronomical Society. There should be a great view of craters, mountains, and other features on the moon, and also other sky objects. Speaking of the national parks, our speaker for the July 17th program is probably the world's leading expert on the opportunities available to do stargazing and astronomy in the national parks. Dr. Tyler Nordgren will talk about this, and maybe he can help you plan on a tour of some of the parks now that it's beginning to be easier to travel around the country. Dr. Nordgren and his Space Travel Bureau have created some great vintage style artwork for national park posters like this. I'm going to let the sky rotate some more to simulate the rest of the night. You could watch the stars of the summer triangle rise higher and higher as the night goes on. And then late at night, you will see Jupiter and Saturn appear in the southeast. Let's watch for them. There's Saturn, and then there's Jupiter in the late evening. As the hours pass and the stars continue to slide by, it starts to get light outside, and in this program, we can even make the sun rise. It's fun to have such power. I hope you enjoy the tour. We'll see you next month.
Well, that was a great program. I love the way that Rich goes through and explains the night sky. And Joel, I don't know if you're still there, but he's definitely reinforcing some of the very things that you talked about in his presentation in such a great way. You know, the funny thing about the night sky is everybody wants to go out and get a telescope, but there's so much to see just with your naked eye at the end of the day, right? So isn't that really great? Yeah. All right, Jim Small and Jeff, we're moving on to our next part of our program where we'll have some of the members of the St. Louis Astronomical Society talk a little bit about some of the objects in the night sky. And so I'm going to let you guys do some sharing, I guess, of the screen, if you can do that. I'm not sure.
Yeah, I've got the PowerPoint first.
Okay, great. So this is Jim Small. He's the president of the St. Louis Astronomical Society. And he'll give us our first tour here. So
Welcome to everybody. And Jeff Carpenter is along with us. He's going to be showing us some of the images he's obtained in the last bit. But first off, let's just say this is the St. Louis Astronomical Society, and you can find us online on either Facebook or on the web.
Showing you
Either of those two links.
images he's obtained in the last bit.
Of course, and this is Gateway to the Stars.
hey, Jim, you might have a backfeed there on your sound. I'm not real sure if that's you or me. I'm hearing some secondary sound.
No, it was me.
Okay, anyway, go ahead, Jim. Sorry.
So here's a photo taken by SLAS members. And if you had a larger telescope, then you can see Alcor and Mizar here. And you can tell Mizar's two stars. If you get a 4-inch or bigger telescope, then you can resolve Mizar into a really nice double star in addition to the part you can see. But here's what it looks like through a library telescope. So here's an image taken that has Moon, Mercury, and Venus from May 13th. Mercury is barely visible. Venus down here by the horizon. And we always love it when Venus is on the horizon, because when it's close to the horizon, frequently you end up with it shifting colors due to the atmospheric turbulence. And that's when we start getting interesting reports. Hey, it's a UFO. It's just hovering there on the horizon. Well, no, it's likely to just be Venus. And here's the picture Rich Pfefferman had earlier with the Moon and Mercury. This is a great shot because it's hard to get Mercury to show up and not get washed completely out by the Moon. So this is a really great picture here. And then here's one from the day before. And if you notice on this one, it's a relatively thick crescent. So this is only a couple days after new moon. And this is actually one day after new moon, most likely. And you can see it's a little closer to Mercury and a much thinner crescent. Now, how do you know that's a waxing crescent? Well, the right-hand side is lit. This is at sunset, so the sun's gone down. And so you'll end up with that part of the moon being lit on the right-hand side. Anytime you see the right-hand side of the moon lit, then it's going to be a waxing. And the amount of coverage will start getting bigger as each night goes on. An image of the Eagle Nebula taken by Jeff. Really fantastic shot. And we'll look at this image a little bit later. And Jeff can talk about the Lagoon Nebula, maybe how he got this shot, etc. And we'll take a look at that in a little bit. One of my favorites, the Virgo Cluster. So keep in mind that all of these are galaxies in this image. And so keep in mind, if it's a galaxy, it's not part of the Milky Way. If you're seeing individual stars, like some of these objects, those are actually part of our galaxy. And so they're very close compared to galaxies other than that. One of the questions I always have for beginners is how far can you see naked eye? And the answers are always, oh, a mile or 10 miles, or, well, you can see the moon, right? That's 265,000 miles. And it gets way beyond that, because if you go out to a reasonably dark sky, you can see our nearest neighbor galaxy, Andromeda, naked eye, and that's 2.5 million light years away. And so you can really see a long ways with your eye without any assistance. Here's the Whirlpool Galaxy. We'll take a look at that with Jeff here in a few minutes. We just passed new moon in first quarter. And keep in mind, we do live stargazing at Francis Park on near first quarter moons. We like that because it's always up in the evening sky. Full moon is coming up on June 24th, and then July 1st will be last quarter. And this is a video taken by Mark Jones of the moon through his 12-inch telescope. Conjunctions coming up, Venus and Pollux, June 21st. A spectacular one, Mars in the middle of the Beehive cluster. And the Beehive is a big enough object in the sky. It actually takes up more space in the sky than the full moon does, pretty much. June 24th, full moon. Then Venus will be in the Beehive. And then Venus will be catching up with Mars. And then Regulus. There'll be a meteor shower called the Delta Aquariids. And then Mars will catch up with Regulus. We just had an eclipse recently, back on June 10th. We weren't able to see it from here because the sun set a little too soon, but it was an annular eclipse. The next one that we'll have is October 14th, 2023. And here's the path for that. That's the path for being able to see annularity. And an annular eclipse is where the moon is just a little bit too far away to completely cover the sun. And so you end up with a ring of fire around it. You may have seen pictures of that from June 10th. But if you go farther west, you'll be able to actually see that. Here's the path, according to Fred Espenek. So again, June 23rd, Mars in the Beehive cluster, 15 degrees above the horizon. It'll be in the evening sky around 9 p.m. You can see the Beehive cluster is really big. So Mars will definitely be sticking out in that image.
One day before a full moon.
And then July 13th, there's Venus and Mars after sunset. In the evening sky, about 9:45. Now, you don't need to remember all this. Here's some astronomy resources. And so you can look for events where there's going to be people with telescopes, etc., or other postings from people that are doing photography in our group. But more importantly, here are some resources that you can use to do some observing yourself. And my favorite is skymaps.com. And let me exchange to a new share here. And if you go to the website for skymaps.com, you can actually download this map. And this is fantastic. You want to do it front and back. Here's a view of the sky for the month, and then a list of all the things going on of importance during the month. And so it's rather fantastic. Now, it doesn't show the planets on here, but it tells you what constellation you can find the planets in, etc. But these show all the significant events for the month, and it's very nice to see. The only thing you might need a little help with, if you didn't notice, there's something a little strange about this map, because normally if you're facing north, east should be on the right-hand side, but it's not. That's because this is not a road map. This is a sky map, which means you have to turn it upside down and hold it over your head to view the sky. And if you put the north end, in that case, in front of you, then the east and west will get reversed, and you'll be able to get the right orientation. Now, that's not the only part that's really good about this. This is even better. Here's information about all the celestial objects, some terms, what you can see naked eye, what you can see with binoculars, and what you need a telescope to see. But it's a terrific download for free. Again, print it front and back. And that way you can use the sky map and you have all the other information as well. Might have to have somebody hold your red flashlight so you can read the map while you're trying to find objects in the sky. Okay, and I think, Don, you're going to show Jeff's images for us?
Yeah, Jeff, you want to show those? I'm sorry. Jeff, you want to show those yourself? You want me to bring those up for you? You're on mute, Jeff.
Sorry. I think if you bring them up, they'll be bigger on the screen. Remember, for some reason, I can't get them.
That's fine, sure.
Yeah, okay.
Screen all of a sudden, we lost that.
Yeah, not a problem. 1 second here. Just let me share it for you, okay? Okay, you see that okay?
Yes.
All right, good. So I'll let you go ahead and you just tell me when to advance forward and I'll move advance forward, okay?
Well, this is actually.
That's the last slide, right?
Right. This is the last slide.
Oh, sorry, there you go.
There you
This was the moon from the 15th. And this is the line that gives you the separation from light and dark on the moon there. And like I said,
This is one of our favorite views too.
mhm.
It's always amazing through a telescope.
This one in the last quarter.
So that line that's the light and part is light and dark. It's kind of like a little border is called the terminator, right? So that's one of the best places you can see detail of the moon. And it's really a lot of fun to look both through binoculars as well as a telescope.
And if you have a telescope view, one of the cool things to do is look right along the terminator. And I like looking for mountain peaks on the dark side that are sticking up high enough to pick up a little light. So you basically get a sunrise in the mountain peak as it comes up over the crater, and that's really cool to look through.
I have the funny thing is that I have them taken with the 9 1/4, which is a lot closer right along that line. But unfortunately, with the 533 camera, it comes out very green, so I didn't even bother to put them in here. But next month, I'll try to put the 294 on there so we get a brighter picture.
Yeah, what's always interesting about the moon is that the features change as the shadows change. You know, sometimes you look at the shadows one way and you see certain things, or if the sun's in a different spot, you'll get maybe even what's called the lunar X. It depends on the features, but it's really an ever-changing object to look at, which makes it all the more exciting and so close, relatively speaking, to other things.
Yes, the video of it is much nicer. I had a video I thought I took, but apparently I lost it.
It happens to the best of us, Jeff.
Correct.
All right. So do you want us to move on to the next screen?
Yeah, if you move on to the next one.
Oh, what is this? This is good.
This is M5, and one of the nice things about that is it's a big star cluster. It's not as big as M13, which is probably the best known. And if you happen to be farther south, Omega Centauri shows up very nicely too. But this is a really nice star cluster to view in a telescope or binoculars. And I think you can see it naked eye if you look really close. You might have to need some dark skies. It's about magnitude 5.5 or so, which is pretty dim. The limit for human vision is about 6 magnitude. And if you don't remember or weren't familiar, the bigger the number for magnitude, the dimmer the object. And so this is a great object, but it's visible in binoculars pretty easily. And it's also relatively easy to find. I'm going to share the screen real quick, and then you can do go back to it, Don, when we get done. But here's a view in a star program. Here's the Dipper. You can arc to Arcturus, and then M5 is just to the left of Arcturus. So if you can see Arcturus, which is pretty easy to see, and let me zoom in here a little bit, you can just have your binoculars and wander to the left, and you'll know when you hit M5 because it'll be nice and bright in a good pair of binoculars. So that'd be a terrific object to look for in a pair of binoculars.
And that's one of the
You
things.
can go back to sharing again, Don, if you want.
Yeah, so we had a request actually a while ago to show again that sky map. And I think for folks that are not accustomed to stargazing, those M numbers that you're talking about, they're ways that astronomers identify objects. There's quite a few of those, and they're called Messiers, right, Jim?
Right. Yeah,
Sure.
Charles Messier got tired of seeing these fuzzy objects that weren't comets, and so he cataloged about 100 of them. And so we are 110 rather, and so these are mapped and located objects, and it's some of the favorites for amateur astronomers because it includes lots of very cool galaxies and nebula clusters and other objects that might be confused for comets back in the day.
Do you mind?
Before we had a
Would you
good
mind-
understanding of what everything was.
I just had a request for you to show that sky map. Why don't you show the sky map on that shows the stars, and maybe show what the M5 is on that as well. Just show that.
Oh, okay. Let me pull it back up.
We do a lot of library programs from the astronomical societies, and there's actually 4 clubs around the metro area, and the sky map is a very popular tool to hand out. It's something you can do a double-sided print, and it's a really good detailed it's like a little instruction manual for the month because the sky does change, and that allows you to kind of find things. Otherwise, it's a bit confusing.
Sorry, I had to pull it back up.
No, it's okay.
So here's the map. And you can, let's see, let me zoom out just a little bit. There you go. So if you find the Dipper, then you can follow that to Arcturus. And now let me zoom in a little bit. Here's M5. So Arcturus, speed on to Spica, or if you go to the left here, you can see M5 where Arcturus is. So all these M objects are objects that Charles Messier cataloged.
Yeah.
And here's descriptions of them.
Why don't you
And
make
so
it
you can
make it just a little
find
bit
those.
smaller. Yeah, make it a little bit smaller here so we can see the whole thing because it's
Right.
scrolling beyond. There you go. There you go.
Yeah, so here's a description of M5. Oops, that's not going to work. Telescope reveals individual stars 25,000 light years away. So that's a distance that's within our galaxy. So keep in mind, if you see stars or clusters or nebula, etc., those are all part of our galaxy. It's when you see other galaxies that you're looking beyond our own.
Yeah, and so what I like about that section right there is that it's under the easily seen with binoculars. So a lot of folks are not going to have telescopes, but this is something you can see with binoculars. And M5 was one of the things you just talked about, and right below that is Mizar and Alcor, which is in the handle of the Big Dipper. So a lot of folks think they need to see only through a telescope some stuff. I've got another request while I've got you going on, Jim, is
Yeah, I've got it.
yeah, so if you want to bring up that extra slide there, so just hang on.
So here's the slide with the resources. So Night Sky Network, this first one, that lets you find clubs anywhere in the United States. So if you're planning a trip and you want to see if anybody's planning a star party around the same time of your trip in your location, you can do that by searching here. So nightsky.jpl.nasa.gov. Another cool one is heavens-above.com. You can enter your coordinates and it will tell you when the ISS is going to come over, Hubble Space Telescope, other satellites, etc. And then, of course, we talked about skymaps.com, and spaceweather.com also has good information about when it might be cool to see uh, northern lights or aurora, you can actually sign up for alerts to be notified when those are a possibility. So if you happen to be heading for cooler climes farther north, that's a good thing to do.
Yeah, actually, the International Space Station is kind of fun. We've actually had a neighborhood party before when it comes over. It's very visible. You don't need binoculars or anything. It's just a bright dot that goes across the sky fairly quickly. So let me go back. And by the way, I got to thank you for showing all that stuff again from the folks that were doing this. So I'm going to go back to sharing the screen. We've got just a few more slides, I think, if I can find it here. 1 second. Okay.
The next one should be M51.
Right. So
The next slide.
there you
Yeah,
go.
the next one will be,
Yeah, so here's what's called the Whirlpool Galaxy. Tell us about this one, Jeff. Nice shot.
yeah, I grabbed this one the other night. I believe this was on the 16th. I was almost finished for the evening, and I just decided to go one more, and this one was there, and I grabbed it. Forget what the actual, I have it here.
Yeah, with the cloudy weather for so long, there was almost frustrating. You almost want to stay up all night because once you get this clear night, it's just nice to be
Oh
outside.
yeah, I did.
Stars.
This was the particular night I did stay up all night that night, and I grabbed this one. Of course, I say by the time I start breaking down and everything, then it's almost daylight. So
Right, right.
this one was actually a late night, and it turned out pretty spectacular, I thought, for just, I mean, this is unretouched. This is just the way it is after it's stretched. I don't do.
Yeah, is that a one-shot color camera?
Yeah, this is the 533. This is through the 9 1/4.
Okay.
So, I
9 1/4 is a 9 1/4 inch telescope.
yeah, the Schmidt Cassegrain. This is the edge. I put 2 on top. I do have another view of this one, but it's through the 4-inch refractor, so it's a little bit further out in the sky and not as close. And so it's nice to have 2 views sometimes, so you get an idea of what is, and it also gives you a perspective of what might be, you know, up there in a dark site that you might only see as a smudge, and then wham, you bring it in real close. So it's kind of nice to see. This is a particularly cool one that I like.
Yeah, that's a great shot. Now, if you want to see that object, I'm going to grab the screen again.
Mm-hmm.
To find that in the sky, here's kind of a view. We talked about the Dipper earlier, and there's the Whirlpool Galaxy right off the end of the handle of the Dipper. So that makes it relatively easy to find. And keep in mind, this is another galaxy, and so this is not close. So this is 28 million light years away. So, you know, when you have an object like that, that's not something in our Milky Way. That's something that's very, very far away. And so you're not going to see that naked eye, but it is, if you have a decent telescope and you have the Dipper. Can you see that in a 4-inch telescope, Jeff?
The Whirlpool, yes.
Yeah.
It does come up, but it's pretty faint. Not as faint as the footprint galaxy that I brought up the following night. That was a that's a what are they? I forget how they frame that on cloudy nights, but that's like a difficult object in their monthly.
But the nice thing about this is it's part of the circumpolar group of stars, which of course kind of rotates around Polaris, and so this never actually gets below the horizon at our latitude. So that makes it kind of handy for that.
No, but I have to wait for it to get closer to the 12 o'clock because
Oh yeah,
I have houses and trees when it's down that low.
right. Oh, just get rid of those.
Yeah.
All right, what's next, Don?
Okay, hang on a second here.
It should be M8 there. and that'll be the last two really. And
that's a lot of our favorite object here.
yeah, that is through the 4-inch. That's through the refractor, and
Very pretty.
that's with the 294 camera. So yeah, these were actually, this was some of the longest exposures I tried. This was a 15-second exposure, and I forget how long I did that far. So I was pretty impressed myself with the way it turned out. And then I did another 15-second, kind of almost a duplicate of it, which is the next one with the 9 1/4. Of course, I would never get the whole thing in with the 9 1/4, especially with a 0.7 reducer on it. But that brings in the H2, the very bright part up there.
The hydrogen alpha, right?
Yeah, that brings that in on the
Yeah, it's a great shot.
Yeah. So I was really impressed with both pictures personally.
Yeah, very nice looking.
Turned out really good.
So this is a huge ball of gas and dust, right?
Correct.
Stars are forming in here. And this is about 4,300 light years away. So, of course, that's part of our galaxy. This is not another galaxy. This is in the neighborhood and relatively close. But that you really have to appreciate how absolutely enormous that area of the sky is. That is not a little piece of gas and dust. To give you perspective, if you move around in our solar system and go all the way out to Pluto, that's only about 5 light hours, not 4,300 light years.
Okay.
So a distant object and very big.
Okay, good.
And there it is. That's the bright section of that nebula, very close up. Again, 15-second exposures. I think it might the SCT might need a little collimation coming up here, but still turned out well.
All right, looks like that's all the slides. And let me check for some questions here. And if we don't have any, then we're gonna go ahead and get signed off. We do appreciate both of your presentations tonight. That was really cool stuff. And Jim, thanks for sharing the idea on those sky maps and everything. That's
Yeah, that was awesome.
So if you want to find the Lagoon Nebula in the summer sky, you can look for something called the teapot. And that's this structure here. Here's the spout. There's the handle. And the Lagoon Nebula is above the spout. There's also a bunch of nice clusters in here. This is toward the center of our galaxy, and it's a really nice part of the sky to look to. There's also a nice globular cluster here. But the Lagoon Nebula is really popular in binoculars and small telescopes. And so you can see that it's just up from the teapot in Sagittarius.
Yeah, you know, the part that I like about that is that part of the sky, no binoculars, no telescope, just go out to dark spot. It looks like cotton in the sky. There's just so much going on.
Yeah.
It's really, really gorgeous. I'm just always so impressed by that. So,
and that's about 450 light years away.
Yeah.
So it's relatively close.
All right, guys, we're going to wrap up here. I'm not seeing any more questions. I'm going to bring up a final screen here. And thank you for all of you for joining us tonight, both on Zoom and Facebook. And again, I apologize for the delay in getting the program connected on Facebook. We will post that to the St. Louis Astronomical Society. You can actually replay Joel's presentation, which is probably what I'll do several times because he's got some really great stuff. On July 17th is our next program. It's Astronomy in the National Parks. That's Tyler Nordegren, which he's a really great presenter and very knowledgeable about stuff. And I hope you'll join us. And we appreciate the Gateway Arch working with the St. Louis Astronomical Society and the International Dark Sky Chapter in Missouri. And thanks again to both of you and to Joel, which I believe is already signed off. And good night, and we'll get this video posted. Good night.
Thank you, Don, for all the work you do here.
Yeah, thanks, Don.
He's
Really
working furiously behind the scenes trying to get everything to work right.
All right. Well, it doesn't always work that way, but we'll try.
It's greatly appreciated. Trust me.
You do a great job.
Yeah. Thank you so much.